Hello, this is COMP4434 Big Data Analytics Individual Project presentation. I am Jinlin and my ID is 180815690. And let's first see what the presentation is going to talk about. Firstly, we are going to talk about my videos and data pre-processing. And then we are going to see the task 1's introduction and two models of task 1. And we will give an evaluation of task 1. Then similarly, we are going to give the introduction and the model of task 2. At last, we are going to show the result of task 2. Let's look at the MapReduce algorithm. We are going to calculate the average rating for each teleplay stored in the file rating.csv. The rating.csv file has millions of data. It is very hard to use the native algorithm in Python to calculate them. So we are going to use the MapReduce algorithm. First, let's look at the mapper. We are going to read the data in the reading.csv file and emit the key value pairs. The key is the teleplay ID, and the value is the corresponding rating for this ID. And the important algorithm is the reducer. Firstly, we initialize a dictionary dict, and we will read the intermediate result, that is the key value pair from the mapper. So the key in the algorithm is the ID actually, and the value is actually the rating. And then we are going to initialize some items in the dictionary. For example, when the reducer receives the ID 1, and it will firstly initialize the key, and it's 1. And the dictionary for this key 1 will be initialized an empty array, and the array will be used to store all the values. And the array can both store the value and store the number of the value. And therefore, after the reducer upon all these results, we can use the average function in the Python to calculate the array's average value. And that is how we do for the reducer. Using the MapReduce function, we can easily calculate the average rating for all the teleplay. Okay, let's look at the data processing. We are going to process the features stored in the teleplay.csv to the vectors. So there are many features in the teleplay.csv, like genre, like tabs, like members. So especially genre, there is a very huge string. For example, anime A may have 3 features, like A, B, C. A may be OVA, B may be fighting, and this is just an example. So there are many features and they are stored in the string. So we must convert this string to a vector or to a set of numbers. So our basic idea is that we are going to create a genre site. This site has all the genre that's showed in the teleplay.csv, maybe 50. And then for the same example, anime A has 3 features, A, B, C. And A's index in the set is 10, B's index in the set is 20, and C's index in the set maybe 30. And we are going to create a general list for A, which has the same length as the general set. And for 10, 20, and 30, they have set this to be 1, and the remaining part set to be 0. So this is the part of genres, and that's how we process this data to the general list. And we also need to notice the scaling. For example, member has a very big numbers in the new For example, some anime which is very hot may have almost 3,000 members in this part, but the other some relatively unfamiliar animes may have only 20 or 30 members, and this is very large scaling. So we are going to part them into different rank. For example, if the number is larger than 1000, we set this part vector to be 3. If it is smaller than 100, and we set this part of vector to be 0. And so we finish the converting the string to the list of integers and also the scaling part. So now let's look at the task 1. First, let's give a short introduction of task 1. This is a prediction task. We are going to, based on the features processed before, to predict the ratings of the new typeplay.csv. And we are going to use the train test split techniques based on the scikit-learn. And we are going to use RMSE as the matrix to do the evaluation. So let's first at the models. The model can be parted into two parts. One is linear regression, the other one is neural network. The linear regression is a relatively naive one. We are going to calculate the loss function and get a gradient. Use the gradient design to calculate the gradient stored in the model. So this is very slow because the size of the feature is too large. And the result we can see later is not very good. And the other part is the neural network. This is learned later in our lectures. And since the feature is still very large and the number of the data is also very large, we are going to use a relatively small neural network, which has only 3 layers. The first layer is the input layer. It has all the features that stored before, and a handling layer with 64 neurons and an output layer. So that's the neural network model. So this is task 1 result. This graph is the result of neural network. The linear regression result is very bad. The RMSE value is extremely huge. But we can see the task 1 result for the neural network is relatively good based on the train split tricks we said before. And there are only maybe 2 or 3 data has a very strange value, but the other one maybe is very relatively similar compared to the real value in the test dataset. And the RMSE value for the neural network model is only 0.6 compared to very large value in the linear regression model. So let's look at the task 2. Task 2 is also a prediction task. We are going to use the user's feature stored in the rating.csv of 53698 and also the features of other movies and other users that's similar to the user 53698 to do the prediction task. So we're going to give a rule of how we choose the people similar as a user. And we are going to firstly get all the movie that has been rated by the user. And for each rated movie by the user 53698, we are going to find all the same rating that from other user. And if this count that the same rating for the same movie of the 53698 from other users count is larger than 10, and we can consider that these two people have similar interests and similar prediction preference. So we are going to choose them as the data set. We are going to use CF because we have many user here, and still we use gradient descent method to learn the model. So this is the result of task 2. The first his table is for the user's original prediction preference. We can see that user give relatively ratings from 6 to 8. And we see there's very large bars in this table because this bar is 0. In my data set, if the user did not read the movie A, use 0 to replace it. So we can see that the 0 is useless in this bar. And therefore, the user's rating is like a normal distribution. So let's see the prediction result. The result is quite similar because there are many ratings that centered in the 6.5 and 7, but the result seldom covered the ratings over 8.5 and 4.5. That may be because the model's drawbacks, because the iteration of the model is very slow. So I chose a relatively small iteration period to do the learning approaches. But the result of the prediction distribution is quite similar to users' original, and we're going to store this result to a new CSV. So at last, we are going to give a short summary of our project. Firstly, we use MapReduce algorithm to calculate the average rate for all the teleplays stored in reading.csv. And we process the features stored in the new teleplay.csv, and we convert those features to the vector flow of the numbers, maybe integer or float, so that they can be processed by the model, both linear regression model or the neural network model. Task 1, we use two different models, and we found that neural network model have a very good performance compared to the linear regression model. And for task 2, we firstly choose the similar user as the target, and then we use CF algorithm to predict the result. The result is relatively good because the distribution is quite similar. And so that's all for the project. Thank you.